Good evening all. Good evening. You're welcome to the tutorials with from Eternity the Schoolboy. Today we'll take a look at mathematics and the topic is number basis. Number basis. Number was basis. This is not a new term to you, right? From right all the way from JS. True of us? JS. So all the way from what? JS. Look at this number. 1,047,33. Look at this number. These numbers are in what base? Do you know? In what base? How do you know that in the base 10? How did you know that this number are in base 10? This number can be in base 2, right? So how do you know that this is in base 10?
Because
I answer.
it's nothing like if it is in base 2, you see, like tell of the right is in base 2. But because you would know right is in base 10, you already know it's in base 10 because all numbers are like
All number did what?
as far as you know signify base, everything is there. Unless you tell us it's
What do you think? In base what? Why? Natural what? Of all numbers. Can if chibuzo na izu na akpade? Izu biaba. Also, come and stay here. Fast. Okay, all natural base for numbers is what? Do you agree with her? Do you agree with her? So common base, right? Just the same way you see common, they say common logarithm is in base what? 10. True of us. Base 10 is common logarithm, right? Common logarithm base. Actually, there have to be an agreed way of doing things. An agreed way of the number, even our normal number. That's what is called enumeration. Yeah, that's what is called enumeration. Our normal counting numbers, our normal counting numbers are enumerated based on what? In base what? 10. Am I communicating? It's just like that. Agree, okay, let's do it in base what? 10. But the language we use, what we use here in base 10 is not the same thing with computer and electronic what? Language. Hope you know. There is in what base what? It's in base what? 2. That's why you see 1 and 0, 1 and 0, 1 and 0, 1 and 0. 1 in electronics, 1 signifies what? 1 signifies what? On, right? 0 signifies what? Off, okay? On and off. 1 on, 0 off. We are not in electronic class. It's for those in electronic engineering. But at least you should know that is in base computer is in base what? Anything you are keying the computer is coded there in the computer listing as what? In base what? As you are keying in whatever number you are keying in is converted to base what? 2. Am I communicating? That's the only one the computer understands. True of us? Good. Now with that that is the why we say okay. And based on that now, if you write a number without a base, we now take it to be in base what? 10. Okay? Now let me, if you want to confirm, you know about place value, like, right? If you want to truly confirm this, try to check the place values of this thing now. You understand what I'm talking about? So let's look at it. If you want to confirm the base, whether it's in base 10, get the place values of this thing. Watch out. What is place value of this? 1,000. How do you know it's 1,000? Should be 1,000 is what? 1 3 power what? 3. True of us. 3 power what? 3. This is base, and this is the power, right? The index. So it's in base what? 10. Now let's take a look at this one now. Are you aware that this thing is saying 400 plus what? 400 plus what? 70 plus what? 0. Are you aware? Which is saying 4 times what? True of us plus what? 7 times what? 10. True of us plus what? 0 what? 0 times what? 10. True of us? Good. Are you aware that this is stating as saying 4 times 3 is power what? 2 plus what? 7 times 3 is power what? 1 plus what? 0 times 3 is power what? 0. Are you aware? Then this is what you have been doing. This is in base what? 10. That's why 10 keeps appearing here. It's in base what? 10. Does it make sense to you now? Does it make sense? Now the same thing with this one now. This is definitely saying 30 plus what? 3. Right? Is it now saying 3 times what? 10 plus what? 3 times what? 10. This is what? 0. This is what? 1. 3 plus 0 is what? 1 times 3 is 3. 1 times 30. Everything will give you what? That. So it's in base what? 10. It's in base what? 10. And this is what we have been doing. By the time we go into conversion, you say that you want to move from one base, from base 3 to base 10. This now will not be replaced by what? 3. True of us. That's what you were doing that time. You say that you assign, start from here. You assign and keep increasing. That's what I just explained now. See that assignment here. 0, 1, 2. The base is what? 10. Does it make sense? So now this is just a kind of an overview of what, for you to understand what we mean by base. Now, based on this now, I want to go to the first part of what I want us to do. I want us to take a look at operations in number what? Basis. Operations in number what? Basis. This is just an introduction I just did. So let's look at operations in what? What we are going to do here is just, okay, before we do that, please, when you hear number basis, now let me list the type of basis we have. This number basis is divided into 2 major parts. We have the whole number, right? And the what? Fractions. Okay? The whole number and the what? The whole and the what? Fraction. Now, if the number you want is just this one, sir. This one now. Just whole number, right? Good. They are in base what? 10. They are in base what? 10. These whole numbers that are in base 10 are called denary numbers. They are called what? Denary numbers. Denary. D-E-N-A-R-Y. Denary. In base 10 as a whole is what? Denary. So if you have base 10, if you have base 10, the whole number. Okay, let me do it this way. After you find out more and complete the table for us. for us and for yourself. If you have whole, right? And fraction, right? Right? So if you have base 10, here is what? Denary numbers. Are we together?
Yes.
Denary what? Numbers. Here is what? Decimal. Have you seen where decimal came from? Decimal, base 10, whole number, denary number. They call them what? Denary. But if there's decimal point, if there's a point there, if there's a fraction, they become what? Decimal numbers. Now, okay. Let me start base 2. The one that are popular anyway. Base 2, you have binary. Binary 2. Binary. Here is we have bicimal. Bicimal. Then base 8. Find out more. Research and find out more. Okay. Base 8. Base 8 is octenary, something like that, right? Then here is what? Octimal. Octimal what number? So if we have base. So if you have base 8, that is whole number, octenary. The one that is what? Fraction is what? Octimal numbers. So that's why we have binary numbers. So this thing can be confusing. That's why I'm explaining this way. So in this class, we'll try to see how far we can go from the whole to the what? Fraction, okay? So just know this point. You can look for other bases and what they are called as a whole, and what they are called as what? Fraction. So this is what I want to talk about in the introduction. So after this now, we go straight to the what? To operations in what? Number basis. Operations in what? Number basis. Now, but the operations we are going to look at here, are addition, subtraction, multiplication, and what? Division. Addition, subtraction, multiplication, and what? Division. So let's start with. Are you aware that we have base 11 and base 12 too? Are you aware? Okay, good. Let's continue. So let's look at addition of what? Addition of what? Addition of a number basis. Good. Addition in number what? Basis. One thing I want you to know is this. Any operation you are carrying out in any number base, please try as much as possible not to record anything that is equal to or more than any digit, not to record any digits. Don't make the mistake of not recording any digits that is equal to or greater than the base you are working on. Okay, that's first point you should note. No matter the operation you are carrying out in number, don't record any digits that is, once the digits come out, maybe either by carrying over, just divide it immediately by the what? The base. I'm not completing, and pick the what? Remainder. Then move the whole part at the other side and keep your operation. Okay, that's one thing I want you to note, because you can never see a base. You can never see a number that whose digits, end of the digits is equal to. No number whose end of the digits is equal to or greater than the base. True of us? And Ebu. Can you carry the land on your head? You cannot carry land on your head. So how can you carry? Because where are you standing on that same land? So how will you carry the land on your head? So how can a digit be greater than its own base? Does it make sense? It can't even be equal to the base. I'm just using natural things that happen around us to tell that it's not what possible. It's true that this land you are standing on, can you carry it in your head? You cannot carry it. So the base should be greater than the what? The digits. Does it make sense? Now let's look at addition. I think I've said one or two things we need to know before we start. Let's look at what? Addition. Oh, I'm cleaning our topic. Let's look at what? Addition. A number what? Basis. Addition in what? Number basis. Now, I think we'll just pick examples and look at the examples and see what we'll get from it. Okay? Good. Okay, let me write out this. Sorry, our reference book for today is New General Mathematics for Senior Secondary School, Book 1. Book 1 by M.F. McRae et al. So this is our reference book for today. So from here we'll pick examples or whatever we are solving, okay? Okay, let's solve this question on the board. Number 1 says 1011 plus 1011 base 2. Everything should be in what? Base 2. Let's go. Let's look at this. Let's go. 1011 plus what? 1011. This is in base what? 2. Let's go. 1 plus 1 is what? 2. Remember I said that you don't record anything that is, any digit that is what? Equal or greater than the what? Base. If such digit appear, divide it by the base. Take the what? Remainder and push the what? The whole part forward and continue adding up, okay? Now let's do it here. 1 plus 1 is what? 2. 2 is equal to the base. So we divide by the base. 2 divided by 2 is what? 1 remainder what? 0. So we pick the remainder. 0, right? Then put the 1 here, right? Let's go. 1 plus 1 is what? 2. Plus 1 is what? 3. We keep dividing, right? 3 divided by 2 is what? Hey, who said that? Can you put that in? 3 divided by 2 is what? 1 by 1. So we put the remainder, which is what? 1. And carry the whole part here, right? 1 plus 0 is what? 1 plus 0 is what? So one can enter. 1 plus 1 is what? 2. You cannot. So you do what again? You divide again by 2, right? And get what? You put 0, right? Take the 1 here, not S2. You bring out that 1. You have what? 1 0 1 1 0. Are we together? Yes. So this is 1 0 1 1. Are you aware that this thing can be twisted? Listen carefully. This thing you see here can be twisted. I can ask you this question in 2 ways. I can ask you this question in 2 ways, or maybe let's say just 1 way. I can tell you to solve this in base 2. Are you aware? Are you aware that you can see this as a question? 2 in bracket 1 0 1 1. You don't need able to tell you that we are talking about what? Or you can simply multiply by 2 straight and get your answer. True of us. So you know that question can be twisted. Now let's continue. Then number number, the B part says, the B part, I can clean, right? I can clean. Okay. Question. I ask. Okay. Yes. No, this and this are not certain. This one means that you should times this thing into 2. Just multiply this. Just this one, look at. This one is what? 1011 plus what? 101. But this one is what? 1011 times what? 10 what? 11. Okay? That's the meaning. Okay. Can I clean? Huh? I used to, yes. This is 2, this times this. This means 2 times this. Which is not saying this plus this. 2 of us. It's not true. This is 2 times this, already. This is not saying this plus this again. It's not true. If you say 2 times 4, 2, this is, if you use it to open this, it becomes what? 2 times 4, which is what? 8. 4 plus 4 is what? 8. Is this in twice? Twice is what? This plus this again. It's not true. Alright, now let's look at the B part of it. The second question says, 421 plus what? 12 plus what? 42. See, are you aware that this is not 421? Are you aware?
Yeah.
Do you know why? We are not in base 10, okay? So just simply say 42. You know that our normal counting number enumeration is in base 10. That's why you say 421. But we are not in base 10. We are in base what? 5. So you don't say 421. It's wrong. Simply say 421. So now let's go. This is in base 5. Well, yeah, let's go. 1 plus 1 is what? 1 plus 2 is what? 3. Plus 2 is what? 5. It's equal to the base. So we divide, right? 5 divided by 5 is what? 1 remainder what? 0. So you put the 0, right? Right? Then continue, push the what? The whole part forward. 1, right? It's 1, right? 1 plus 2 is what? Plus 1 is what? Plus 4 is what? 8, right? So let's go. 8 divided by 5 is what? So we write the remainder what? 3. Then continue with the what? 1 plus 4 is what? 5. 5 divided by 5 is what? 1 remainder what? So we put the remainder right and bring down the 1. So this is the answer in base what? 5. Okay? So this in base 1 is 1030 in base 5. Huh? Which one? This is T0E plus TEE. It shock you? Huh? Don't worry, we'll get there. Oh, it's simple. Don't mind that thing there. It's a very simple thing to do. Don't let that thing confuse you. It's very simple. We'll be centering. Nah, man. What is it? Eh? Any issue? What's that? Which one is that? Which one is that? This one. All of them. But you understood the first one, right? This is the same pattern. You know here that we are working in base 5, not in base 2 now. This is base 5. So whatever you get, you try. If it's a 5 or above 5, you divide by 5. Take the remainder, then push the whole part and continue what the same thing we did in this one. Here is simply 1 plus 2 is what? Answer me. 1 plus 2 is what? plus 2 is what? Is equal to the base. Now you divide by 5. 5 divided by 5 is what? You put it 0. Take the 1 and put it right. 1 times 1 plus 2 is what? 3. Plus 1 is what? 4. Plus 1 plus 2 is what? 3. Plus 1 is what? 4. Plus 4 is what? 8 divided by 5 is what? No. How many 5 can we see as a whole number in 8? Inside 8. 1. What is remaining? 3. 2 is 1. 1 remainder what? 3. So you write the remainder and push the what? Whole part here. Add it here, becomes 5. It becomes 5. 5 divided by 5 is what? 1 remainder was 0. You put 0 and there's not S here again. You bring down a 1. That's why it's 1, 0, 3, 0 to base 5. You know, your face was looking somehow before. Now it's glowing. Huh? Child, Cynthia said that she wants. I come and solve it fast. That's good. I like that. Oh yeah, help us with C. So Cynthia, thank you. I like that. This is how I like my class to be. Just come out. Don't stay and be doing what I don't know. Come out. Solve it. Fail it, and you will learn it. No, you just solve here. It's better you fail it on the board than to fail it in the hall. It's better to fail it on the board than to fail it where? In the hall. So where do you prefer to fail? In the board. So don't fail in the hall, but if you must fail at all, let it be where? On the board. Yes. Hey, done? Huh? Okay. I explain what you did. Talk to us. I'm not here again. I'm here now. Talk to us. Shit from me. I'm now a student. Talk to us. Voice, so the way my voice feel this class, even people in that class hear my voice. It's not true of us. Oh yeah, vocal.
Because it is not that was there, which is repeated sign. 11 or 7, 22 divided by 12, then T is then, right? Small t. The right small t, then carry this note 1. So 1 plus 11, 12 divided by 12. Goes to 0 remainder 1. 10 plus 10, 20 plus 1. Plus 1. By 1 goes to 21 divided by 12. Wow.
Okay. Is that all? Okay. Huh? Ask. How is what? Okay, she's asking how is E11 and T10?
Teacher says.
Teacher says. Hey, teacher say what?
First letter for T for pen is T.
Okay.
And first letter for is
11 is what?
11.
Did you get what he said? All right, thank you. Please let's encourage him, please. Let's encourage him, please. Let's encourage him. Go and sit down. Go and sit down. Thank you. Actually, let me explain something here. I like the courage. Now listen. Actually, you know the one with the base we are used to. Highest is base 10, right? But we also have base 12. We have base 13. Now, but to avoid confusion, you know that if you have a number in base 11, if you have a number in base 11, one of the digits can still be 10. True or false? True or false? One of the digits can still be 10. True or false? Now, how will it look like when you have a number in base 11? You have something like this: 10, 5, 9, something like this. Now, in base what? Base what? 11. Where this thing is what? Actually 10. It can be confusing, right? Because you also can have 1059 in what? Base 11. So how will you know which is which? Can you have 1059 in base 11? Can you? Because they are all less than 11. True or false? Now you also have this 105. So, but this is 10. This is actually 10. You can have 1059 in base 11. So what do we now do to avoid what? Confusion. Okay? To avoid that confusion, we use the first letter of 10 to represent it, 10. So that's why you have one like this: T what? 5, 9 to base what? 11. Does it make sense? Now you may have a number in base 12. Look at it. Let me use this one as an example now. This is in base 12, right? This T means what? 10. If you want to write it that 10, see what you write. You something like this, right? 0 what? 11 to base what? But this is somehow, right? And you cannot also come and write 100. It's confusing. They won't know whether it's 10 or 10. So to avoid such confusion, now the first letters are used to do what? Represent them. So this is actually 10, 0, 11. This is what? 10, 11, 11 in base 12. So that's what he now added and got 19 OT, not 19 19 what? OT. So how do we now solve it? Which is exactly what he did. He got it. This is we know that E is what? 11 to base 12, right? So 11 plus 11 is what? 22. It's above base 12. So you divide by the base. 22 divided by 12 is what? 1 remainder what? 10. But you cannot write 10 here. You use what? T. And take the 1 here and put here. 1 plus 0 is what? 1. 1 plus 11 is what? 12. It's equal to the base. You divide. 12 divided by the base, which is 12. You get what? 1 remainder 0. You put 0. Move the whole part and add it here. 1 plus 10 is what? 11. Plus 10 is what? 21. You divide by, it's above the base. You divide by the what? The base. 21 divided by 12 is what? 1 remainder what? 9. You write the remainder, right? Carry the 1 and put here. You bring it down. You have 19 OT. This actually means 19010. But because of that confusion, you put T. Does it make sense now? Does it make sense? What is it?
Is it only in 11 and 10 that this normally occur?
No, it depends on the base you are working on.
Okay, now we have something like 10, 11, 10, other ones. Give other example.
If you have 9, see, you can invert. This is mathematics. Are you aware that you can invent your own? Let's assume you are solving something now. You can invent your own symbol. But what matters is this. Try to that's what is called key. If you use a symbol, at the end, say what that symbols mean, okay? If you like, you can use X. I hope you know. Are you aware? You can use X and Y. But what matters is that and say that X is what? 10. Y is what? This. Simple. That's what matters for you. You are free to use any symbol, but what matters is this: specify what it means. So if you have 19, you may decide to use NI, or you may decide to use NT as 19. What matters is maybe it's in base 20 in the something like that. 19. You have 19. You can use any symbol to represent it. What matters at the end, say what it means. It become a problem for you if you end up not saying what to use, what actually what means. Okay? All right. How can you use what? Who said that? Okay. What if we have 25? What are you going to do?
That's my question.
T has been used. So what are you going to do? Use what? TF. Who told you it's TF we should use? I'm not the one that put that one now. Okay, that's okay.
You say that you produce your own method or formula.
It's not method. I say symbol.
Okay, simple.
What matters is this:
Okay.
indicate what it means.
Like this one, that means that T and E is now common.
No, the T is common.
Okay, that's not
It's common. But that one different. It's common. Okay, I'm just telling you something. No, so I just saw someone ask something about white. I'm trying to explain something that these things are just symbols, but T and E are common. They have been used, and it's now well known that they can set questions like that. But actually, the most one thing you should know is this: there's what is called key in anything you are doing. Any symbol you use in some certain things, maybe if you are answering questions, try to indicate the meaning of what you use. And I'm telling you, if someone that actually know what mathematics is what marking your script, and you put X, maybe you are solving, so maybe they will give you something else that will lead to in base 12. They will give you ordinary numbers, so they will give you like 1094. 1 plus 2056 in base 12 to add up. Maybe when you're adding it now, you get something. If you get 13 or you get 10, look at this is 10 now. Let's say this is 4 plus 6 is what? 10. And this is in base 12, right? And I decide to put X here. And after solving, and we get that X is what? 10. Someone that actually knows that most of these things I don't know, but the point I'm making is that someone that actually knows mathematics will understand what it means. You mean by that class. That's why you put the key. The key is very important. Okay, but because 10 T is common. It's common. There's nothing wrong there using with one that is what? Common. But I'm telling you that these things are just symbols to represent what? Those numbers that are above. These numbers are above 10. They are 10 and above. You can be confused for 10. True of us. So that's what they do. That's the basic thing I want you to understand here. Even if you are marking your script and use X, where you have issues that if you at the end of your X, you didn't tell me what X is. That's where you have issues. I'm not completing. I'm trying to say this represents. Okay, in your graph, you can choose anything you want. At the end, you have your key. True of us. In this graph, this S in vertical axis, this represent blah blah blah. There's a reason for that. True of us. You indicate what it. So if I want to read your graph, I'll go to your what you. And I don't know what you mean by what you. So the same thing. Okay. In your mathematics, maybe if you are solving calculation, you can, if you like, use Z. Let Z it be so thing. Anybody that knows, you must not be X. Let X. You can even let B be. Let Y. Let Z. Let K. True of us. So that's what I say. But the point is that define what you are using. Any symbol you are using, you do what? define what, because that symbol is not the answer. It's what it represents is the what? Answer.
Like now, T and P is common. Is there any other document?
That's common.
Apart from T and P.
A number, most of the textbooks I've seen stops at T and E. But I'm telling you with my full chest that if you use any symbol there, any good mathematics examiner will mark it. Okay. Number what? On what? Number what? No, it's your assignment. You can do your assignment. I have no business with this thing till tomorrow morning. Till when? Next tomorrow. I have no business with this thing till next tomorrow evening. So now, this is what addition. Any questions so far? We have roughly 11 minutes to go. We have roughly 11 minutes to go. Okay. Question we can solve before. Okay, let's look at this one. See, subtraction is also, if addition is this simple, that means subtraction is also what? Very simple.
When you add that one you are writing, it will be exactly that later.
How? Explain. Let me understand what you mean. Okay, you mean in subtraction?
Yes.
Don't worry. Let's. I don't think we have any issue in addition, right? So let's just look at subtraction. I will write out some questions on the board. We will take it off from there. All right. Let's solve this one on the board. Let's solve this one on the board. All right. Let's go. 1101 minus what? 11. All right. Let's look at this one. Are we together? Yes. No, we are not. We are not. Ching, are you with us? No, you are not. Now let's go look at this one now. 1 minus 1 is what? 0, right? This is in base 2. 0. 0 minus 1. So what do? We take 1 from here, right? Why do you call it 2? So you just call it 2 like that. Is that how you name numbers? You just call it 2. You multiply by the base you are working on. Okay. Multiply by the base you are working on. Okay. So 1 times 2 is what? 2. I'm explaining why it happened like that. Okay. Don't mind. I'm not quite jacket. Just don't mind you go around and say, but you don't just call it like that. It's in your promise that they told you that you call it 2. You call it 10. You just take 1 from nowhere, call it 10. Is that how they name numbers? They told you that because they know that that at another level you won't understand what happened. Okay? So you multiply by the what? By the base you are working on. So it becomes what? 1 times 2 is what? 2. You add to this one, right? You add or subtract. You add to this 0, right? It becomes 2. 2 minus 1 is what? 1. What's remaining here? 0, right? You bring it down, right? Here and come. Here is what? So the answer is what? 1010 to base what? 2. Let's look at this one. 321 minus 113 base 5. 321 minus what? 113 base 5. 1 minus 3. Can you go? So we can take 1 from here, right? And if you take 1, you multiply by the base you're working on, right? 1 times 5 is what? 5. So 5 plus 1 is what? 6, right? 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 Yes. 6 minus 3 is what? 3. Good. What is remaining here? 1. 1 minus 1 is what? 0. Here come 3. 3 minus 1 is what? 2. So this is 2 over 3 to base what? 5. Let's work on this one. 405 minus 217, all in base 5. Let's go. 5 minus 7, base what? 8, sorry. They are in base 8. 1 minus 5 minus 7, take 1 from, you take 1 from 0, right? If you take 1 from 0, you call it what? 8. You call it what? You multiply by what? 8. If you take 1 from 0, you multiply by what? 8. 8 plus 5 is what? 13. 13 minus 7 is what? 6. Is this 6? What is remaining here? 7. In that 0, what's remaining here? Minus 1. True or false? How? What's it how? but it's okay, listen. 0 minus 1 is what? 0 minus 1. So why is it how again? You took 0, 1 from this 0. What remains here is what? Minus 1. Is it not true? It's still now. From where?
Maybe assume that we've not found this 13 now. This 16 now is 5 can't subtract 7. We have to move back to the next one, which is 0. So 0 cannot borrow 1 from 0.
Why? How? So you are telling us that 0 minus 1 don't exist in calculation. At this your level. At this your level, you cannot have 0 minus 1. There's no answer. Is it undefined? Is 0 minus 1 or 1 undefined? Does it have an answer? 0 minus 1 is what? Hey, that's not 0. 0 minus 1 is what? It has an answer. So don't say it's not possible. That is your primary school thing. Because they know that you can never understand that 0 minus 1 is what? Minus 1. At that level. Okay? Now, so let's go. So if we have 0 here, take 1 from this 0 now, call it, multiply by what? The base, right? Which is 8. 1 times 8 is what? 8. Add 8 to this place. 13. 13 minus 7 is what? 6. What is remaining here? Minus 1. It's still less than 1, right? Then take 1 from here, right? Multiply by what? The base. It becomes 8. 8 minus 1 is what? 8 plus minus 1 is what?
8 plus minus 1. 7 plus minus 1. That's 8 minus 1.
Which is what? 7. So 7 minus 1. 7 minus 1 is what? 6. What's remaining here? What's remaining here? 3 minus 2 is what? 1. So 116 to base what? 8. I know what you wanted. That thing they told you in your primary school. Start from here. Borrow from here. Then add. Then borrow. No, it's because you told me that what I'm doing is wrong. That's why I'm saying that it's not wrong. It's correct. You know, here you unlearn to do what? Learn. You unlearn to do what? Learn. You are here to learn something new. So don't hold on to that one you know. Try to learn something what? New. Unless I see. Do you know the beauty of this? You may have an array of numbers. You may have up to 8. That is if you have such 7. See, by the time you go to this, just because you want to subtract this from, maybe you have this 4 2. But just because you want to do 7 minus 8, you go to Kafanchan and start borrowing. You borrow and put. You borrow and put. You borrow and put. You may borrow from here, put here, try to cross here. The one you borrow will disappear. You make mistake and commit errors. True or false? To avoid all those, you go from the beginning and start borrowing, start coming down. Just start borrowing straight from here and do your what? Your thing to avoid what? Errors. Once you know your signs, once you know your what? Signs. I know that this science is one of the most, it gives us a very serious trouble. There are people now that don't even know that x minus x is minus 2x. They don't even know what it is. And there are big girls and big boys.
S minus S is minus 2S, because you know minus S, then minus 2S. Minus
S minus S is what?
He didn't say minus S.
No, she said, no, she's right, she's right. You know it now, so why do you have issues here? Okay, I have awakened your sign issue, right? It's good. At least in every class, you try to grab something new. That's why we are here. So, minus S is what? Minus 2S. S minus S is what? Good. Now, look at this. Okay, let's solve this one. 905 minus what? 2 base what? 12. Let's go. 15 minus 9. So take 1 here, right? Multiply by 12. Becomes what? 12. 12 plus 5 is what? 17. 17 minus 9 is what? 17 minus 9 is what? 8. What is remaining here? Minus 1. Take 1 from here. Times by what? 12. 12 plus minus 1 is 12 minus 1. 3 of us, which is what? 11. 11 minus 0 is what? 11. So you put here what? Let's use E, right? So what is remaining here? 8 minus 5 is what? 3. So 3E8. 3E was 8. So it's what? Yeah, thank you. 2 base what? 2 base 12. Okay, I think with this, I don't think you have any issue in subtraction, right? Unless maybe by the time we do review, like here are some implied questions. Maybe by the time we do review, focus on implied. There's some questions that may be implied, they're not that direct. You may see the question, they may actually want you to subtract. You know, this one are too direct, true of us. There are some questions you see that you know that you actually need to do what. Like this question now. This is an implied question. By the time you read it and start with it, you now start seeing the operation you need there. But I want you to do it. Even this one is somehow implied. All right. Do you have any question? Any question? Okay. In the absence of any question, I think we'll stop here for today. We have actually. In what? No, we are still dealing with whole numbers. Okay? We'll still go over to what? If we are done with whole numbers, operations in whole numbers, we go over to what? Fractions. Okay? That's when we start seeing that one you are talking about. All right, I think we'll stop here. It's nice being with you spending 2 hours of my life with you. And see you next time. Wednesday is Rasa. Thursday is we continue here on Thursday. All right. God bless you.